Okay, this example says that 150 kilopascal sample of neon is at 57 degrees Celsius. Assuming the volume remains constant, what would be the pressure of the neon if the temperature is decreased to 25 degrees Celsius? As always, we start by writing down what we know. So our P1 is 150 kPa. And our T1 is 57 degrees Celsius. And we know that we're going to have to convert that to Kelvin. So we have 330 Kelvin. We are asked to find the new pressure, and the new temperature is 25 degrees Celsius, which is 298 Kelvin. When we look at our variables, we see that we are going to use Gay-Lussac's law, which is P1 over T1 is equal to P2 over T2. To get P2 by itself, you can multiply both sides by T2. And you get P1, T2 over T1. And then you can plug into your equation. P1 is 150 kPa. And T2 is 298. And T1 is 330 K. We can see that Kelvins cancels out, giving us kPa for our units, which is a correct set of units for pressure. 150 times 298 divided by 330. And your calculator should say 135.455 when we talk about significant figures. We have 2, 3, and 3. So when we round our answer to have two significant figures, we should get 140 kPa. Let's try another example. This example says that a sample of oxygen gas has a pressure of 1.73 atmospheres at 21 degrees Celsius. At what temperature would the gas have a pressure of 3 atmospheres? So we write down what we know. P1 is equal to 1.73 atm, and T1 is 21 degrees Celsius. When we convert that into Kelvin, we get 294 K. Our second pressure is 3 atm, and we are asked to find our second temperature. So Gay-Lussac's law is P1 divided by T1 equals P2 divided by T2. To solve for T2, we cannot just divide both sides by P2. That would just give us 1 over T2. I like to cross multiply. And then to get T2 by itself, we can divide both sides by P1. And we get T2 plus T1, P2 divided by P1. Again, I don't care what algebra you use in order to get this equation here. I just need you to be able to do it. So we plug into our equation. And we say T2 equals 294K times 3 atm divided by 1.73 atm. And our atmospheres cancel out. And so we do this in math in our calculator. And we get 509.827. When we go back and look, we have 3, 3, and 2. So when we round our answer to have two significant figures, we get 510 Kelvin.